Okay, today is the 4th. This is the wrong packet, sorry. Let me get the second period packet. Today is the 4th. And today we're going to be looking at angle pairs. We actually have a couple lessons about special angle pairs. We talked about some angle pairs last time, complementary and supplementary. Today we're going to be talking about things called corresponding angles. We're also going to be practicing one of the things that we did last class, which is looking at a picture or diagram and determining what kind of equation we could write to learn more information about that. So if you guys could flip and find 2.1.2 in your notes packet. The first problem in our notes packet does not have the figures in your packet, so you're going to need to look up at the screen here. What I'm going to ask you to do in this problem is to talk about the relationship that you see there. Your options are listed up here. You're going to write either equal, complementary, or supplementary in each of these blanks. But then I would also like you to write an equation. Okay, so if you guys could just look up here, and then I'll give you some time to do this. So for part A, you're going to look at these and you're going to decide which of those three words best describes the relationship between A and B. And then I want you to write me an equation that has A and B and an equal sign in it. Now, it might be something like A plus B equals a number, or it might be something like A equals B. You guys decide, okay? So for these four figures in your packet, please determine what is the relationship, equal, complementary, or supplementary, and write me an equation. I'll give you a couple minutes to have a look at that. And once you're finished, go ahead and spy on your neighbor, see if you agree. For those who are finished with this task, I want to talk about something that's a very detail type thing, not super important at this point, but I did notice a couple people who, instead of writing A plus B equals 180, wrote the measure of angle A plus the measure of angle B equals 180. And this is a very technical way to write this. You do not have to do it this way, but if you did, I'm very impressed. Yes. Oh, okay. Yep. So this when I read this little tipped over capital L is the angle symbol. So I would read this as the measure of angle A plus the measure of angle B equals 180. And that's fine, or A plus B equals 180 is fine as well. All right, folks, let's pause on the side conversation. I want to make sure we got this. This next one was the key thing from Monday. Do you guys remember the vocabulary word for two angles that are formed when lines are crossing and those two angles are right across from each other? It starts with a V. Do you remember the name of that angle pair from Monday? Vertical angles. I'm sorry, I stole your thunder. Yes, these are vertical angles. Now, what did we learn about vertical angles on Monday? They're always, they're kind of across from each other, but what's the relationship? Do they add up to something, or are they equal to each other? They're equal. So, the relationship here is that those are equal angles. And if they are equal, then my equation would just say that C equals D. If you wanted to include some additional information, the reason they're equal is because they are vertical angles. If you were not here on Monday, that was the major definition that you would have missed. These two angles are vertical angles. There's another pair of vertical angles in the same picture. They're not marked, but this top angle and this bottom angle would also be vertical angles. Could I get you guys to pause on the side conversations, especially because we're going over something that you missed on Monday? Thank you. So these angles would also be vertical angles, and they would also be equal to each other. All right, F and G, what's the relationship here? Are they equal to each other? We don't know. We don't know for sure, but what we do know is that they're together, and if we think of them together, they're forming this 90-degree angle, which makes them which of our three relationships? Equal, complementary, or supplementary? Complementary. And again, if you have not already, for those two, please write me an equation. F and G would add up to 90. Last one here, before we get into the relationship, what is special about this triangle in this last figure? What is special about this triangle? This is something that was on our last test. Is it equilateral? Equilateral means it has three equal sides. Nope. We're close, though. It has two equal sides. What do we call a triangle with two equal sides? Isosceles. It's an isosceles triangle. And you probably already knew about isosceles triangles having two equal sides before you started this course. But one of the things we learned in chapter 1 was that isosceles triangles also have two equal angles. Okay, that's a fact that I am expecting that you know at this point. Are we good on that? Isosceles triangles are always going to have two equal angles. They are the angles that are right across from the equal sides. So the relationship between H and K then is that they are equal. And I would write H equals K. Does anybody have any questions on that first problem? All right, I'm going to get you started on the second task here. I'm going to give you sort of a shortened version of these instructions here. So we've got this tile pattern over here, and what they're going to ask you to do is go through here, and they say to do in different colors. I'm actually going to use symbols. Match up all of the angles that are the same size. So I'm going to start with this upper right-hand corner, and I'm going to put a symbol in here. I'm going to put a little smiley face there. You can use a different symbol if you want, or if you grabbed a marker or you got different colored pens or pencils, go ahead and mark this angle in some way that's going to be identifiable. And then I want you to go through the rest of the figure here and mark any other angles that would be the exact same size as that, also with a smiley face. It might be useful to use your tracing paper if you're not sure. So I could trace this angle and then move it over and say, ooh, that looks like it's the exact same size, doesn't it? So this would also be a smiley face. Once you've done that, if there are any angles that are not smiley faces, pick another symbol and mark any of those that are equal. If you can find a third angle that's equal to other angles, use a third symbol or color. Does anybody have any questions about what I'm asking you to do? This will be a pretty quick task, I think, for most of us, so go ahead and get after that, please. All right, let me get caught up to you, and then we will continue on here. So this is what I was seeing on folks' pages. Did anybody end up using more than two different symbols? And I'm going to use different colors, and I'll just use dots to make it simple. All right, so we're going to get into some new properties. And this is a particular shape called a parallelogram because these lines are parallel. The fact that we marked, thank you. The fact that we marked this kind of pattern of angles here gives us a property of parallelograms. And that property is that in a parallelogram, opposite angles are always congruent to each other. So those two angles are going to be congruent, and these two angles are going to be congruent. One of the big things that we're going to be doing in geometry this year that's going to be different from your previous years is it's not enough for us to just know that. I also need you to be able to justify that. I need you to be able to explain to me why you know for a fact that these two angles that I've marked in orange here are congruent. Does anybody want to take a try at that? This is going to be some of the more challenging stuff that's going to be on our next test, is explain to me how you know that these two things are equal. Would anybody like to take a try? What else do we know about parallelograms? You guys wrote a whole bunch of properties about parallelograms down last class. What else do you know? Yes. I'm sorry, can you speak a little bit louder? If the angles were not equal, it wouldn't be parallelogram. You're getting a little ahead. That's awesome. So we're going to talk about if-then statements here in just a little bit. And then doing converses. You guys are making it hard for me to hear other people. Okay, can you stop, please? Thank you. What else? What have we done with parallelograms? We've talked about things like, well, I'll give you a hint. Tell me something about the symmetry of a parallelogram. What type of symmetry does a parallelogram have? We've learned 3 different types of symmetry, but really only 2 that are useful to us. Does it have reflection symmetry? It seems like it should, but it doesn't. We've tried reflecting and it doesn't. Does it have rotational symmetry? It has rotational symmetry. So I'm going to go ahead and trace this. You're welcome to trace it as well if you'd like, but I want everybody's attention up here. Please do not miss this. Because if you cannot currently answer my question, how do I know for sure that these 2 angles are congruent, then you need this information, okay? Here's why. Here's my explanation. Parallelograms have rotational symmetry, which means I can take this angle right here, and I can rotate it and get it to match up with that angle over there. Okay, and what do we know about rotational or rotations? Rotations are a rigid transformation, which means it does not change the size or the shape of things. So my explanation would be I can rotate this angle to match up with this angle, and because rotations are rigid transformations, then those angles have to be the same size as each other. That would be an A+ answer on a test question where I ask you to justify that those 2 things are equal. Does anybody have any questions about that? So a lot of the times when we're justifying, especially at the beginning of this course, we're going to be talking about transformations. That's why we spent so much time with them in chapter 1. Okay, I want you to keep that in mind because we will be using transformations to justify another property in just a moment. All right, could you guys look with me at number 15, please? We're going to get into some vocabulary here that's going to be really important. You're going to be using this quite a bit. So what we have here is that we've zoomed in on a particular portion of that tile pattern from up top, and we're just looking at a couple of parallel lines. Can you guys spot the parallel lines because of the markings? They have the little arrows on them. So here's my parallel lines. And then this other line that's crossing over both of those. This line has a special name. It is called a transversal. Could you please label that line right now with the word transversal? A transversal line cuts through 2 other lines. A transversal line cuts through 2 other lines. All right. I need everybody to grab their tracing paper, please, and find angle X in the diagram and trace it onto your tracing paper, please. You got that angle traced? A moment ago, we proved that 2 angles are equal because we were able to rotate and get them to match up. This time, I would like you to translate that angle. We are not rotating it, we're not flipping, we are just sliding it. Can you take that angle X and translate it and get it to match up with some other angle, one of the 7 other angles in this picture? Only sliding. We are not rotating. So I could rotate it and get it to match up with this, but that's not what I'm asking you to do. I'm asking you to translate it. Can you translate? Can you move up or down or diagonally to get it to match up with another angle? And if so, what is that other angle? What's the other angle that you're able to match it up with? B. So if I take this and I slide it right up along that line there, I haven't rotated it, I haven't reflected it, it is perfectly matching up with B. Okay? So here's our second piece of vocabulary for today, and that is corresponding angles. Could you guys please underline this in your notes? Corresponding angles are angles where you can take one angle, like angle X, translate it or slide it along your transversal and find the matching angle. Without rotating, without reflecting, if you can slide it along the transversal, match it up, you've got a corresponding angle. So what we know is that angle B and angle X are corresponding angles. Could you please find for me 3 other pairs of corresponding angles? And we'll abbreviate corresponding like this. So if you could write down corresponding angle pairs. We already found that angle X and angle B were corresponding. Can you please find me 3 other pairs of corresponding angles in this picture? If you're a little confused right now, what I'd encourage you to do is look at angle W. You could trace it on your tracing paper if you need to. Take that angle and slide it up and see what it would match up with in the other intersection. Angle W would match up with what other one if we were to slide it up? Can you find me 2 other pairs? Can somebody give me 1 other pair that I don't have on my sheet already? I got X and B, I got W and A. What else we got? Y and C. If I slid Y up from here to here, those would be corresponding angles. Angle Y and angle C. Thank you. How about 1 more? Say it 1 more time. Z and D. Angle Z. If I slide it up to here, it matches up to angle D. Those would be our 4 pairs of corresponding angles. Do you guys feel confident that you could spot some corresponding angles? All right, let's do a quick problem with this. We're going to actually give some values. Could you please go back up to your figure here and label angle B with the number 60 degrees? 60 degrees. Using that, I would like you to label all of the other angles in this picture. There are 8 in total, so you have 7 more to label. I want you to find the number of degrees for each of them. For example, B and C are vertical angles. We already learned that vertical angles are the same, so 60 degrees also right there. See if you can label all of the angles in the picture. Think about vertical angles. Think about supplementary angles. I see some supplementary angles there as well. All right. What I'm seeing from folks is that you put 60 here and here as well. And then are you recognizing that we do have some supplementary angles right here? We have two angles that are coming together to form a straight line. So they would add up to 180. What's the angle Z going to have to be? 120. And that's going to match up with that because those are vertical and those are also going to be 120s up there. We feeling okay about that? All right, you guys doing great? I'm going to move through this last piece pretty quickly. My next task is on number 17 on the next page. If you could please flip over. And I'm going to just have you follow the instructions that are given here. I'll give you a couple minutes to do this. It says use tracing paper if you need to. If not, you're welcome to do it without. But I want you to decide if the corresponding angles shown have the same measure. If they do, go ahead and figure out what the other angle is, any other missing angles that are marked. If you don't have enough information to find some of the angles that are marked, please explain why. Okay, just a couple minutes there. So see if you can find the values of X and Y in each of these pictures using corresponding angles or any other properties that we know at this point. And if there's not enough information to find either the X or the Y or both for one of these problems, tell me why. Just a couple minutes. Let me know if you need any assistance getting started on that. All right, wrap up if you're having a conversation about these problems right now, wrap those up in the next 30 seconds. I want to talk about these. Does anybody have any questions while we're wrapping up here? All right, let's talk through this. Do we have enough information to find X here? Yes, what is it? 135. Once we know that, can we tell what Y is? What is it? Okay, pausing for a second. Shh. Hey guys, I want to address this question. Please pause for a second. Yes? That's an excellent question. So the question is, if we've got a line, don't all the angles have to add up to equal 180? Yes, they do. For each of the, so you're talking about the transversal here, right? And if I put a line here, you're saying, don't these two things have to equal 180? Yeah. Absolutely. But hang on just a second. We've got another transversal that's coming in here. So there's going to be another 180 right here. Does that answer your question? Yeah. Now, what you said really gets at something super important, though, that we're going to be using later on. So don't miss this. If we have an intersection like this, and we're looking at all four of these angles, or all of these angles going all the way around, what do those add up to? Those add up to 360. That was a great question. Thank you. Okay, are we feeling confident now that these are both 135? I talked to a couple of people. I need you to know, if I ask you, what is the vocabulary term that describes X and Y? I need you all to know the answer to that question right now. They are vertical angles. X and Y are vertical angles. They are formed by these two crossing lines and they're across from each other. Okay, if you did not know the answer to that, could you please circle those two and write down the word vertical angles underneath them? And continue to do that until as soon as you see those vertical angles on a picture, you're able to say that word vertical angles, okay? You're literally going to hear that word and say that word and write that word probably 1,000 times this year. Yes, vertical angles we will be using a ton. Okay, let's talk about part B. This is 135. Do we have enough information to find X? How much? We have enough to find Y. Let's start there. What would Y be? 45. How did you know it was going to be 45? Hey, folks, I need you to pause the side conversations, please. How do we know this is going to be 45? Because we've got that 180 showing up again here from that straight angle. Do we have enough information to find X? Did anybody try tracing X and seeing if you could get it to match up with one of those other two angles? It doesn't, does it? That looks like it's close, but it's a little bit over. And this one definitely doesn't either. So we don't know x. Okay, let's move on. What about in part C? Did x match? If we traced it and moved it over, did x match the 135? It did. What about y? Y doesn't match, but do we have another way we can find it? Yeah, we've got, can somebody use the vocabulary term that best describes x and y in this picture? They're not vertical angles, they are supplementary angles. Supplementary angles add up to 180. Okay, folks, I really need you to be engaging with these vocab words. That's going to be the biggest challenge for us on the next test. Being able to look at those and know, oh, those are supplementary angles. What's special about supplementary angles? They add up to 180. Okay, how about in D? These do not match, but they look like supplementary angles to me again. Add up to 180. Did anybody try tracing y and seeing if it would match up to any of those known angles? Did it work? It did? Which one did it match? Did it? Hang on. I didn't think it did, but I have been wrong so many times today already. It's close. It's close, but not quite. Not quite. So I don't think we can find y in that one either. All right, now, this is the key part, okay? One of the key parts of our lesson, I want to talk about conditional statements. There is something special about corresponding angles, but not all the time. Please don't miss this, okay? In this picture, x is corresponding with this 135, and they are equal. But in this picture, these are corresponding angles. If I slide this position over, it matches up to this position. They are corresponding angles, but they are not equal. So are corresponding angles always equal to each other? No. The answer is no. What special condition has to happen in order for corresponding angles to be equal to each other? It happened in A, and it happened in C. What special was going on in A and C that was not going on in B and D? Yes, same? We got parallel lines, okay? So I want us to write down the property of corresponding angles, but we're going to do it as a conditional statement. Conditional statements are if-then statements. So follow along with me here. This is underneath part F. If something, then corresponding angles are equal. What has to be special? If the lines are parallel. Do you guys know the symbol for parallel so you don't have to write it out? Looks like a double L like that. If lines are parallel, then corresponding angles are equal. I'm actually going to write congruent. We'll talk more about equal and congruent later, but for right now, I'll just think of that as equal. If that's confusing to you, don't worry about that squiggle. We'll just say equal for now. All right, I want to give you a preview of what we're going to do later, and then we're going to move on to our assignment because I want you guys to have some good time for that. So if you guys will give me just 2 minutes more, then we will go on. We're not going to finish these together. You can put your pencils down. I just want you to pay attention, okay? I've had this conversation with a couple people today. I asked you, why are these two angles equal to each other? How can you justify it? And I've gotten answers like, well, they look like they're equal. Or I can tell they're equal. I know. But in this course, we're going to need to be a lot more specific than that. So I want to explain to you, if I gave you a problem like this on your test and asked you to find the value of x and to justify it, your answer is much more complicated than just x equals, 65 degrees. Okay, so I just want to give you an example where we're headed. Now, I don't need you to be here yet, but I want you to start opening your minds to this is what we're going to be doing later. I got some folks that aren't paying attention right now. Can you pick your head up off your desk and just look up here for a second? I will be quick, okay? here's the answer that I would give you. I would say x is, or I would say this angle right here is equal to 115 degrees because they are corresponding angles, and corresponding angles are equal when the lines are parallel. I would write all that stuff down. I would abbreviate as much as I could, but I would say this is also 115 because they're corresponding angles which are equal when the lines are parallel. And then I would say this angle up here is also 115 degrees because it's corresponding to this one, and corresponding angles are equal when the lines are parallel. Then I would say because these two angles are supplementary, they must add up to 180, and then I would do 180 minus 115 and get my answer of 55. If all I wrote was x equals 55, you'd be looking at like a 1 out of 10 on a test question. Okay, so that's where we're headed eventually. You're going to need to be able to justify these things. So as we're going through this chapter and we're introducing these vocabulary terms and we're introducing these properties, it's really important that you're engaging with these. As you're working through your assignments, I want you thinking about not just why are these two things equal to each other, but not just what is the value of this angle, but what are the vocabulary terms that you can use to describe those relationships. If you can force yourself to do that while you're doing your assignments, you're going to have a much easier time later on when we get into where that's going to be a test question. Okay, question. Is it 65? Yes, it is 65. Thank you. Like I said, 18th mistake today. Okay, so if I asked you to look at part C and I asked you the question, are these two angles equal? Yes or no? This angle right here and this angle right there, are they equal? Yes, they are. If I asked you to explain why, you would need to say something about, we've got a vertical angle here, and vertical angles are equal, and I've got a corresponding angle here, which are equal because the lines are parallel, and then I've got another corresponding angle here, which are equal because the lines are parallel. Okay? I don't expect you to be able to do that now, but again, if I can get you to start practicing with that vocabulary, it's going to make your life easier. My students, when we get to chapter 3 in geometry, a lot of times my students start really suffering and getting frustrated because they don't know the vocabulary and they don't know the properties that we went over in chapters 1 and 2. Okay? So please make sure you're engaging with that. Okay, thank you guys for your attention today. You've got the assignment